So let's continue, from the lecture note. We will solve the alternative solution with f determined by iteration. For the detailed calculation of this alternative solution, refer to SIGO 2013, pages 128 to 130. No? As an initial trial value, we use f. The value of f is equal to the computed critical local buckling strength equal to 19 point. I think this is not 71, but this is 76. This one, FCR. The local buckling strength, no? This is 19.76 KSI. The value obtained above after using an initial value of f is equal to Fy, no? The purpose of iteration. Then compute the same formula or equation for the effective with B sub E. 1.92 times the design thickness square root of E over F, small f. Am I correct? Yes. Small f times the quantity 1 minus 0.38 over PT. Square root of, this is 66. Square root of E over F. Small f. So mao ni siya. The answer is, this is F, no? Which is equal to this FCR. B sub E is equal to 6.65 inches. The total loss in area is therefore, the same calculation, no? Before, 2 times this is the unreduced width. From 8, this value B, we get this one from this provision in the NACP 502.3-4 or AISCB 4.1. For the unknown corner radius, the unreduced length, no, is equal to the total length or height of the HSS minus 3 times the design thickness. That mo ng 7.652. Nagigamit natin dali 7.652 minus B sub E, which is 6.65 times 0. Design thickness 0.116. Answer is 0.2325 inch square. So that the reduced area is the gross area minus the total loss in the area. So the answer is 2.68. Then compute for Q sub A. Q sub A is effective area over the gross area. No? The value is 0.914. And since Q sub S is 1.0, the Q is 0.941. Then, use this Q for the computation of this limiting value to compare the slenderness ratio, diba? 4.71. Since we have to reduce this one because this is for local buckling. Square root of E over QFY. So the answer is, using this computed Q, no, 0.19141. The value is 123.7. The KL over R, which is we solve this one in the other video, is 105.3, which is less than, no? So, kung less than, thus use the NSCP equation 505.7-2 or AISCE 7-2. This one, this formula for critical buckling load for the local, no, buckling load. Critical buckling strength, actually. So, using the value of Q, no? Then, FE this is the Euler's strength. We computed this one as 25.81, no? The answer is 21.26 KSI for the critical buckling strength. And comparing the FCR, which is 19.76, di ba? 19.76. Hangtod, continue the procedure. So, gamito ni mo ni siya. After this one, na nakuha man ni mong FCR, gamito na po ni mo ni siya as FY. So, by iteration, use the same procedure above, no? Until convergence. Convergence meaning, hangtod magpareha sila. Like, you try F is equal to 21.26, katong nakuha ganina, di ba, kanisya? Then, using the same procedure is nakuha na to ang V sub E, no? The effective width, which is 6.477. Then, the total loss in the area, 0.2726. Then, the effective area is 2.427. Then, Q is Q is effective area divided by the gross area, 0.8. So, that FCR is 21.15. Then, comparing the 21.26. So, hapit na. Then, use na pod ni siya again. Use F na pod, no? Mahimo na po siyang F. .26. Continue iteration until so kani siya sunod na po ni mga iteration mahimo na po ni siyang F is equal to this 21.15. Gamito na po ni mo the same procedure, solve for the BE, the total loss in the area, the effective area, then Q, then FCR. Hangtod magpareha na siya until convergence, no? Until convergence is maabot ka aning 21.16 KSI. Then, solve for the nominal load, nominal strength, equal to FCR times the gross area, 57.13 kilopounds. Compare this one to the flexural buckling load or the global buckling, which is 58. Still, by iteration, the local buckling controls, no? Kay mas smaller man siya. Smaller than the flexural buckling or global buckling, which is 58.91. And the LRFD design strength, no, is this resistance factor 0.9 times the nominal load or strength, 57.13. So, the design strength is 51.4 kilopounds. And the allowable strength through ASD solution, just divide this one by by the factor of safety 1.67 or 34 kilopounds. Or in terms of stress, allowable stress is, or divide this one by just the, pwede naman na siya i-divide lang sa gross area 2.7, or using this relationship, you know, we discussed this one, di ba, already, 0.6 FCR. So the answer is 12.7 ksi using the iteration f. So compare with the previous computation between iteration and the previous this one, no? The design strength is 48 kilopounds, and for LRFD and for ASD is 32 kilopounds. By iteration, greater than, no? Mas dako ang by iteration, 51.4 kilopounds, and for ASD is 34 kilopounds. Meaning, using this F is equal to Fy, the design or the value is slightly lower, no, than the iteration. Okay. Then let's continue for the design of compression members through tables, no, using the tables.